Debris flows are a flowing mixture of mud, sand, rock, and water that move downward along the sloped terrains or gullies under the force of gravity. When debris flows occur, a torrent of soil, sand, and rocks gushes down the creeks and forms alluvial depositions in the valley, posing a hazard to human lives and properties, and causing severe damages to the ecological environment. Since 2002, the Soil and Water Conservation Bureau, SWCB, Council of Agriculture, receives real-time rainfall data from the Central Weather Bureau and announces debris flow warnings according to the rainfall-based warning criteria of debris flow occurrence as a means to provide government the reference for disaster response, evacuation, and refuge. In recent years, in order to precisely monitor the hydrological conditions during a debris flow event, the Soil and Water Conservation Bureau establishes various debris flow monitoring stations in high-risk areas, each with advanced monitoring instruments to collect on-site debris flow information. The advanced monitoring instruments include rain gauges, wire sensors, geophones, ultrasonic water level meters, and infrared CCD cameras. The information detected by the sensors mentioned above not only can improve the accuracy of the debris flow alert model based on rainfall thresholds, but also can provide reference for the design of SABO engineering, the countermeasures of disaster prevention, and academic research. A rain gauge is used to record on-site rainfall. At the moment, the warning model for the debris flow alert uses rainfall intensity and accumulated precipitation as warning indexes to determine whether rainfall has reached the threshold, and thereby release timely red and yellow alerts to high-risk areas where debris flows are likely to occur. As debris flows gush down the channel, the flow will break the wire sensor placed in the spillway of Sabo Dam, hence indicating the occurrence of debris flow. This is the most common sensor for debris flow monitoring. In addition, when debris flows occur, the geophone can detect the ground vibration generated by the collision between boulders and channel bed. The result of signal analysis can then serve as references to determine the occurrence of debris flow. An ultrasonic water level meter is used to measure water level through the transmission of ultrasonic waves. The water level data can be used to evaluate the parameter of debris flows. Through the infrared CCD camera, the hydrological process of debris flow can be vividly recorded. In recent years, the Soil and Water Conservation Bureau is actively involved in the research of automatic image identification technology, through which the characteristics of debris flow can be identified and provided to the disaster prevention authorities as references. By using advanced monitoring instruments and highly efficient transmission systems, the debris flow monitoring stations conduct real-time monitoring on potential debris flow torrents. During typhoon periods, instruments at the debris flow monitoring stations are employed to collect all-weather real-time information. By making use of the satellite transmission to overcome the limitations of topography and weather, the monitoring system can transmit field information to the Emergency Response System at the Soil and Water Conservation Bureau, which will then instantly display images and information via the Internet to provide information to the decision-making authorities. In order to enhance the mobility of debris flow monitoring systems, the Soil and Water Conservation Bureau has made incessant efforts in developing the system and finally invented its own mobile debris flow monitoring stations. With the portability of monitoring instruments, the stability of the station, and the ability to operate independently, the station is capable to overcome the limitations of topography and weather to conduct in-depth monitoring at the front line of debris flow. The standard operating procedure for mobile debris flow monitoring stations is as follows. In the event that the Soil and Water Conservation Bureau receives a typhoon alert from the Central Weather Bureau, the SWCB should, based on the possible path of the typhoon, interpret areas where debris flows are likely to occur and dispatch mobile debris flow monitoring stations to carry out the monitoring task. The Mobile Debris Flow Monitoring Station is currently equipped with sensors including a rain gauge, infrared CCD camera, and geophone. The mobile station is also equipped with an intelligent power system, operating independently for at least 72 hours in the field. Furthermore, in order to expand the monitoring range of the Mobile Debris Flow Monitoring Station, the SWCB dedicates itself in the development of modules for monitoring instruments, seeking to use the rapid assembly technology for monitoring instruments to transmit relevant information to mobile debris flow monitoring stations via wireless network. This greatly increases the efficiency of on-site monitoring. The Soil and Water Conservation Bureau will continue utilizing the latest technology to conduct long-term debris flow monitoring, providing real-time debris flow information for all levels of disaster relief authorities. This allows the decision-making authorities to understand the trend of debris flow and to draft effective emergency measures accordingly, thereby improving the nation's capability in slopeland disaster prevention and protecting the lives and properties of residents in mountainous regions. The Soil and Water Conservation Bureau of the Council of Agriculture of Executive Yuan strives to work with you.